All right, guys, we are going to do number 42. So the Von Mitt Comet in zero gravity astronaut training. This is the image right here. And equipment testing. NASA flies a KC-135A aircraft along a parabolic flight path as shown in this figure. So this is going to be the figure. And it's going to fly. And now, as it's going to fly, think about the motion. You're going to be standing in the ground, and it's going to be traveling up. So you're going to be kind of, maybe if I'm not sure how this works, to be honest, but I do understand motion pretty well. So the aircraft climbs from 24,000 feet to 31,000 feet. Oh my God, I'm going to have to convert. Where it enters the zero parabolic with the velocity of 443 meters nose high at 45 degrees. I can imagine that if it's going to enter zero gravity, folks, the aircraft cannot accelerate. So the aircraft would have to be in free fall along with the person inside of it in order for you to observe the zero gravity. So I believe that's really what it is. So it's basically saying that aircraft climbs from 24 to 31,000 feet. From here, this is where it enters zero gravity. And it enters at a velocity at 143 degrees nose high at 45 degrees. So this is going to be 45 degrees nose high and 45 degrees downward. And exit with the velocity at 145 degrees north down. So it's basically going to travel at that velocity. And I would imagine that it would stop accelerating at that point. So it's going to go up into a free fall mode, and then it's going to go down. And then once it goes down, then maybe the aircraft would accelerate, and then you would you might, yeah. Anyways. During this portion of the flight, the aircraft upward acceleration of 0.8 g. Moving in the vertical circle with a radius 4.13 kilometers during this portion of the flight, occupants of the aircraft perceive acceleration at 1.8 g. What are the aircraft speed and altitude of the top of the maneuver? So, what is the aircraft? So I'm going to say that the aircraft speed velocity. All right, so it's asking for the speed at this maneuver right here, right at 31,000 feet. So the speed of the aircraft is really just going to be 143 meters per second. Cosine of 45 degrees, which is going to be, speed here is going to be 101 meters per second. All right, so that's for part A. For part B, what is the altitude at the top of the maneuver? So now, since we found the speed, let's find the altitude at the top of the maneuver. So let's find out how far it rises. So I'm going to let this position be 0. So I'm going to set up my equation is going to be the y max is going to equal the speed. So in order to get the y max, the by is meters per second times sine of 45 degrees, which is going to be the same as that. So the y max of the y is going to be y squared over 2g. Would be the max. So here you're going to have 521.66 meters. Now I'm going to convert it. So the y max that this travels is going to be 9,970 0.46 meters. All right, so once you solve for that, let's see what part C is. What is the time interval spent in zero gravity? Well, what is the time spent in zero gravity? Well, as you can remember, we're just going to do the standard kinematic motion, which is going to be the 0 is going to be the initial velocity, which is going to be vyt minus gt squared over 2. Once you solve for that, so you have 2vy divided by g equals t. That's the time it takes. 2v divided by j. which is going to be approximately 20.64 seconds. All right, let's see what part D is. So I did solve this already, so I actually put 1.8 divided by the other one, but at this point, this is where it's going to have 0.0 g. So I'm going to kind of approximate this and say that the tangential speed is this direction that it's going times the gravity. So in other words, I am going to just say, so the velocity is going to be the square root of 0.8 times g times the radius, which is going to be 4.13 kilometers. So we're going to put 0.8 times gravity times 4.13. So the tangential velocity is going to be approximately 180 meters per second. All right, folks, we are done. I hope this helps you guys, and I hope you enjoy.